Okay, here is the helper video for page 256 as promised. There's a couple things I want to go into a little bit of depth on and before I do problems 3 and 4. So the first thing that I want to talk about is when they had division. So on the notes that you were taking on how to add, subtract, multiply, divide, powers, and roots of complex numbers, he did this example, zeta divided by w, and he had 1 plus root 3i divided by 2 plus 2i, and then he multiplied by what's called the complex conjugate, which is 2 minus 2i. And so if you multiply something, if you multiply a fraction, if you multiply the bottom by something, you have to multiply the top by the same thing because a number divided by itself is 1, so we're just multiplying by 1. So why are we doing this? Why are we taking 2 plus 2i and multiplying it by 2 minus 2i? So if you haven't seen this before, like if you didn't take Algebra 2, you might not have seen this before, but it's related to rationalizing denominators. So back in geometry, if you got an answer like 1 over the square root of 2, and we'd say, oh, you're not allowed to have a square root in the denominator, so you would multiply the denominator and the numerator by the square root of 2, because then you would end up with square root of 2 over square root of 4, which gives you the square root of 2 over 2. Okay, that's rationalizing the denominator. Okay, well, what if you had 1 over 1 minus the square root of 2? What would you multiply to get rid of it then? So what you would do is you would multiply by 1 plus the square root of 2. And I'll show you what happens if you do that. If you change it to a minus to a plus, what happens is when you multiply out these binomials together, the middle term is going to cancel out. The middle term is going to cancel out. So on top, I have 1 times 1 plus the square root of 2, which is 1 plus the square root of 2. And on the bottom, I have 1 times 1, which is 1. 1 times root 2, which is root 2. Negative root 2 times 1, that's negative root 2. And then root 2 times root 2 is root 4. And negative times positive is negative, negative square root of 4. And then we can simplify that. I have 1 plus the square root of 2. And on the bottom, well, the square root of 4, well, that's just 2. So I'd have 1 minus 2. 1 minus 2 is negative 1. And then the positive root 2 and the negative root 2 would cancel out. So I would be left with this. And then I can reduce this further. It just so happens, since this is a 1, I can go ahead and divide both of those by 1. Or I can do it like this, 1 over negative 1 plus square root of 2 over negative 1, which just gives me negative 1 minus square root of 2. Okay, so I started here. This is where I started, and I wanted to get rid of the radical in the denominator. So in order to do that, you multiply by what's called the conjugate. And what happens by having one of these be a minus and the other one being a plus, it makes the middle terms drop out. So that's exactly what they were doing up here. So they gave you this problem, z divided by w. And in order to get rid of the imaginary number in the denominator, what we can do is multiply by the conjugate. And this happens to be called the complex conjugate because it's a complex number because it has the imaginary part. So when I do this, when I multiply these together, 2 times negative 2i is going to cancel with 2i times 2. Those are going to cancel. So I'll get rid of my imaginary number in the denominator. So that's why the host of that video set it up this way. And so then he didn't bother to finish it, but we could go ahead and finish it. So on top, I have to multiply these binomials. So 1 times 2 is 2. 1 times negative 2i, negative 2i. 2 times root 3i would be 2 root 3i. And then that times that would give me negative 2 root 3 times I squared. Okay, 2 times root 3 and I times I, and positive times a negative. It's a negative. Okay, and then on the bottom, I'm going to have 2 times 2 is 4. The middle terms, this one and this one, those are going to cancel out. So I'm not even going to bother writing them. because I'm getting positive 4i and negative 4i. Those are going to cancel out. So then the other term is going to be 2i times negative 2i. That would give me negative 4i squared. And then look what happens there. I squared is just equal to negative 1. And a negative times a negative is a positive. So in my denominator, I end up with 4 plus 4, which gives me 8. And then up here, we'll look at this mess up here. Okay, here, I squared. Again, that just equals negative 1. So that's going to be negative 2 times negative 1 gives me positive. Okay, so let me write these down. I've got 2, and this one is going to be plus 2 root 3, because the negative 1 times negative 2 root 3 gives me positive 2 root 3. That's the real part of the answer. And then the imaginary part is going to be this. So here I can factor out my I. So I'm going to factor out my I. This is kind of ugly. So I'm going to put plus I, and I have negative 2 plus 2 root 3. I could mess around with that negative sign. I could have pulled it out. So I could do that. I could put minus I. And then this would be positive 2 and minus 2 root 3. Okay, so again, as he was pointing out in the video, dividing complex numbers is a real hassle. But the reason why he wrote multiplying by 2 minus 2i is to get rid of the imaginary number in the denominator. And you do that by writing the conjugate. This is called the conjugate. When it's the exact same terms, it's just one of them is adding and the other one's subtracting. Those are called conjugates. Okay, another thing about problem 2 on page, what page were we on again? Page 256, is you can actually do the whole thing on your graphing calculator. So notice in the directions, it had said do it by hand and then check your answers with your graphing calculator. So if I get my graphing calculator and I look at the problems, say A divided by B. Okay, so on page 256, number 2C, it has A divided by B, and we know that A is equal to 2 plus I, and we know that B is equal to 3 minus 2i. You can actually just put it straight into your graphing calculator. You can do this. Oops. So I'm going to do parentheses 2 plus I, close parentheses, open, and then divide by, open parentheses, 3 minus 2i, close my parentheses. Okay, I can just type it in, press enter, and here it is. Okay, notice that it is giving me these crazy decimals. Okay, if you do it by hand, you're going to get fractions. And then you can check if you do it by hand and then you do it this way, you can check and see if you get the same answer. Okay, so another thing though is that in that video, it says that you can change them to polar form, and then you can use the polar form shortcut. Okay, so if I take these and change them to polar form, again, I can do that on my graphing calculator. I can change them to polar form. I showed you a video how to do that. And then you can use the shortcut with the polar form. So you have a whole lot of options on this. And, you know, IB, Math Applications and Interpretations, is really big on using the graphing calculator. So you might want to try some of these problems one way and then try others another way and see how it works out. But I did want to explain why in the video the narrator did this, changed the plus to a minus. He was trying to get rid of the imaginary number in the denominator, much like we do when we rationalize the denominator in a fraction. Alrighty. Okay, so moving on to problem 3. Problem 3 has to do with a quadratic, and it's saying the question says write x squared minus 4x plus 5 as the product of 2 linear factors. So basically they want us to factorize this. So if we were to factorize this, well, x squared is x times x. And to get 5, I have to have 5 times 1. And then I need to figure out, well, pluses or minuses. Well, to get a plus here, these either would both have to be minuses, or they'd both have to be pluses. And if I cross multiply this now to check my middle term, this would give me negative 5x and negative 1x would be negative 6x. So that doesn't work. If I change them to pluses, well, that would give me positive 6x, so that's not working. So it's not factorable. So if it had been factorable, say I had x squared plus 6x plus 5. Let's say the problem had been this. I could factor this. So if I cross multiply these, I get 1x plus 5x is 6x. So I know this factors to x plus 5 and x plus 1. So this is what we want to end up with, but except for this problem. So since we can't factor it, the way that we can get to this point is by using the quadratic formula. So I'm going to go ahead and do it on this one because we'll be able to check our answer real easily. Using the quadratic formula, x equals negative b plus or minus square root b squared minus 4 times a times c, all divided by 2a. And I hope you don't mind me going fast, but a is just 1. Okay, so I end up with negative 6 plus or minus the square root of 36 minus 20, that would be the square root of 16, over 2. So I get negative 6 plus 4 divided by 2 and negative 6 minus 4 divided by 2. So that gives me negative 2 divided by 2 is negative 1. And here I'd get negative 10 divided by 2 is negative 5. So notice when I solved these, I got negative 1 and negative 5. Oops, I'm off the bottom of the video. Sorry about that. But when I factorized it, I got the opposites, right? I got positive 1. That's my negative 1. So when you factorize a quadratic, you end up with a form x minus p and x minus q. So what we're trying to figure out is for this one, what is going to be my p and my q, and we can get that by doing the quadratic formula. So that's what you want to do. So since it's not factorable and we're doing a unit on complex numbers, you better believe it, it's going to be an imaginary number. Okay, so basically you're trying to figure out what's p and what's q by using the quadratic formula. Okay, so you can try and do it yourself, or you can stick with me right now and I'll do it with you. So what we're going to do is we're going to do, okay, x equals negative b plus or minus the square root b squared minus 4 times a times c, all divided by 2a. So x equals 4 plus or minus the square root 16 minus 20 is negative 4 over 2. So x is equal to 4 plus or minus, okay, I know the square root of 4, that's 2. And I'm left behind the square root of negative 1, which is I, all divided by 2. And now I can split this into 2 fractions, 4 halves, plus or minus 2i over 2. So I get x equals 2 plus or minus I. So those are my solutions. But remember, getting the solutions is not the same as factorizing, okay, as we saw over here. So now what I need to do, this is my p and my q. My p is going to be 2 plus I, and my q is going to be 2 minus I, because of the plus and minus symbol right here. So when I factorize this, and I'm running out of room, so I'm going to put it here, I'm going to have x minus all of this, 2 plus I. And then the other factor is x minus, okay, because that's part of the formula, the other one, the other solution. And there it is. So that is what we're looking for on number 3. I have now factorized x squared minus 4x plus 5. That is what we're looking for. And we can see our 2 solutions right here. All right, question 4, problem 4. Problem 4 is real similar. We have another quadratic, x squared plus px plus q. Okay, p and q are in slightly different context here, is equal to 0. And it says one of the solutions is 3 minus I. Okay, so when they say one of the solutions is 3 minus I, that's like we were saying one of the solutions is 2 minus I. Oops, I can't see that. 2 minus I. Okay, so it's, man, you still can't see it. What is wrong with my dock camera? There we go. So here are my solutions. So we know that one of the solutions is 3 minus I. Well, when you have imaginary solutions, it's always going to be, one of them is this, the other one has to be 3 plus I. Because we get the minus I, that happens because of this situation right here. We have the square root of a negative. That's the only way you're going to get the I. So if you have one with a plus, there's got to be one with a minus. They always come in pairs. Okay, there's no way that this is going to change and be both of them are going to be pluses. One of them is always going to be a minus, one of them is always going to be a plus if you have an I, right? So I know that these are going to be my two solutions because of the nature of these imaginary solutions. Just has to be that way. So therefore, I can set up this problem just like I did on problem 3. I can work my way backwards. If I were to factorize this, knowing the solutions, I would have x minus one of these, and I would have x minus the other one. And now, in order to figure out what this is, I can just multiply this all out. And then I will be left with my P and my Q. So I'm going to go ahead. I think let's see, should I keep doing that with you? Yeah, what the heck. There's a couple ways you could do it. You could distribute the minus sign first and then multiply it out. But I'm going to just go ahead and multiply it out. So I'm going to have x times x. That's x squared. And I'm going to have x times negative 3 plus I. So that's going to be minus x times 3 plus I. And then I'm going to do this one. I'm going to have minus 3 minus I times x. Minus, I'm going to put the x in front. 3 minus I. And then the last one, I'm going to have negative times a negative is going to give me a positive. And 3 minus I times 3 plus I. Okay, so notice over here, I've got my conjugate. I've got a complex conjugate. Complex because it has the number I, and conjugate because they're the same terms, but one's a minus and one's a plus. So remember what happens here when I multiply this out, the middle term is going to go away because negative 3i and positive 3i are going to cancel out. Woohoo, shortcut. So when I multiply this out, I'm going to get 3 times 3 is 9. And I'm going to have negative I times positive I. So that's going to be negative I squared, right? Negative times positive negative. I times I is I squared. We know that I squared is just equal to negative 1. So this is the same as 9 minus negative 1, which gives me 10. Okay, so this term gets to 10. Okay, the first term is just still going to be x squared. Oh, so look, we're already partway done. Looks like Q is going to be 10. All right, now we got to do the middle terms here. So I'm going to distribute my negative x. So I'm going to get negative 3x minus ix. And I'm going to distribute this one. I'm going to get negative 3x. And negative times a negative gives me positive ix. And then I'm going to combine my like terms. Negative 3x and negative 3x is negative 6x. And then negative ix plus ix, oh, those cancel out. How sweet is that? Those go away. So this term was my x squared. These two terms together gave me negative 6x. And then this last term gives me positive 10. So here is now my quadratic, x squared minus 6x plus 10. And if I look back at here, this is my P and this is my Q. So P is equal to negative 6 and Q is equal to 10. So there you go. There's your big giant helper videos. And I hope you are okay with everything else. If you need me to go over something else in a video, just send me an email and I'll make another video. Bye-bye.